Good morning or afternoon, everybody. This is Mr. Bratz, and today we're going to be taking a look at our radical notes. Now, today's notes are really going to be broken into two major parts. We'll have a third calculator part, which your individual teachers can explain to you more in depth if you have questions about that. But today we're going to be talking about the differences between radical form and exponential form. This is a little extra bit of information, but you can think of radicals as fractional exponents. So normally we have like x to the second power, and we've been doing a lot of lessons that deal with these power or these exponent operations. And today we're going to be talking about how to recognize and write exponents or radicals for something like this, x to the 2/3 power. And it won't be anything crazier than that. We're just going to be talking about how to recognize them and how to write them in different forms. So first things first, let's go ahead and take a look at our two different types of forms. So let me go ahead and zoom in here. Oh, if it'll let me try this. There we go. So we're going to start off over here on the left side where it says radical form. Now there's about 3 or 4 different parts. There's 3 parts labeled in this picture, and there's a 4th part I'm going to want you to pay attention to as well. So the number that's outside of what we call our radical sign, the radical sign is this gray symbol. Some of y'all have seen it, and many of y'all have used it before. The number on the outside is called the index. Now, if you do not see the index or a number outside of this radical sign, there's going to be an invisible 2 where the index is if you do not see a number. And you're going to see what that looks like when we actually work with some examples. The radicand, it's this funny sounding word, it's describing everything that's inside of the radical. So we have the radicand, the thing on the inside, or the stuff, the expressions on the inside, and we have the index, this little number that's on the outside. Now, if we take a look over here on the right side, we can see how we can take a fractional exponent and write it in radical form, or how this transformation occurs. If you have a to the 1 over n, so it's basically saying if you have a fractional exponent, you can rewrite it where the denominator goes on the outside, or the denominator is your index, the number that goes on the outside. And there's a little breakdown here where we have a to the m over n, where m and n can be 2 different numbers, so you can think of it like a to the 2 over 3, where 2 is m and 3 is n. So we're just using variables to represent any number it could be. And it's showing where you would put these numbers. The numerator, or the top number, the m, goes inside and it becomes the power. The n, the number that's in the denominator, is your index. And we show a final way to rewrite it. Now we're really going to be focusing on getting to this middle expression. We're not going to be going to this very end part. So let's go ahead and practice a couple examples. So it says, write each in exponential form. They've given me something in radical form, and this very first example is what I'm talking about. I don't see an index, or I don't see a number on the outside, so there's an invisible 2. Inside the radical, the b is the radicand, or the stuff inside. We have an invisible 1 right there. All variables and all numbers have a little invisible power of 1, so we just rewrite it. And if I look, I'm going to draw a little arrow. We want to change it from this radical form to exponential form. So the number inside the radical will go on top of our fraction. The number outside will go on the bottom. So this will be equal to b to the 1/2. The power on the inside is the numerator. The number on the outside, the index, is your denominator, the number on bottom. And we're going to repeat this process for all of these. You're going to write in the index if you don't see one, and you're going to write in the power if you don't have it. So no index means there's an invisible 2. No power or no exponent means it's invisible 1. And this time it's going to be the exact same thing, just with a different base or a different variable. We're going to have y to the 1/2 power, or 1 over 2. Power on the inside goes on top. The index number goes on bottom. So on number 3, it looks like this time we do have an index. We have a number outside as 3, but no power on the inside. So I went ahead and wrote that invisible 1 right there. And this time, changing it from radical to exponent form, we're going to have x to the 1 over 3. Inside goes on top, outside goes on bottom. Here we have a power on the inside. We have x to the 5th. Our index is 4, the number on the outside. So I'm going to have x to the 5 over 4. And that about covers it for half of what we're going to be asking you to do today for your assignment. You're going to be changing something from radical to exponential form. And it's not that crazy. And especially because if you can do it one way, you can do it the other way as well. So for example, if we take a look over here on the right side, it says write each in radical form. So I have a bunch of expressions in exponential form, and this models very closely what we have up here in this little formula. A to the m over n is equal to the n on the outside with m on the inside. So this is m, this is n, and the form is n on the outside, m on the inside. So I will have the square root of 4 x to the first power. But because we don't like to write those invisible numbers, I'm just going to say x, and we're done with the problem. Here, y to the 1/2, we have m and n again. So the index number, the number on the outside, is 2. Y to the first power. Now this is a tricky one because both of these numbers, a variable raised to a power or something raised to a power, if it's 1, we don't write that in. And something new that we're introducing today is if you have a radical sign whose outside number, whose index is 2, we don't write that number either. So we're really just going to say y to the 1/2 is equal to the square root of y. These two are equivalent. We don't write the 1 or the 2. Moving on here, we have mn. So the square root of the n number goes on the outside, so 3 is the index. X to the second power. Number on top goes on the inside. And then finally, they just did a little switch here. Number on the outside, let me label it m and n. N goes on the outside, and the top number goes on the inside. And it's the exponent or the power of the variable of this term. Now an index of 2 means we don't write it. That's an invisible 2. And we're done with this problem. Or these sets of problems anyways. So I'm going to zoom out. And I mean, they're literally the exact same type of problems. You could start with 1, go to one form, and then you can work your way backwards as well, just to double check. Now, moving on here, we are going to do 2 things. We're going to apply what we just learned, changing each of these from radical to exponential form. It says simplify each radical. So we're going to change it to exponential form. And then we're going to try to simplify if possible. So let me go ahead and zoom in. And I'm just going to label this very first one. We have n and m. We should have x to the m over n, which means my answer should be x to the 6 over 3. Now, If you can simplify that fraction, 6 divided by 3 or 6 over 3, you need to or you should. 6 divided by 3 is just going to give me an answer of x to the second power. So we're going to be simplifying these these exponential forms to just get one final answer. So all of that was equal to x to the second. Doing the same thing over here, we have x to the 15 over 5. Number inside goes on top, number outside goes on bottom. 15 divided by 5 is just x to the third power. Moving on to example number 3, we'd have x to the 12 over 4, which is just going to be equal to, well, 12 divided by 4 is just, well, that's x to the third again. 12 divided by 4 is 3. And number 5 is an example where we don't have an index. Again, we need to remember that there's an invisible 2 on the outside. So I'm going to rewrite this expression. We'd have 6 to the second power divided by 2. And 2 divided by 2 is just 6 to the first power. 2 divided by 2 is 1. And 6 to the first is just 6 by itself. Anything to the first power is just whatever the base is or whatever that number or variable is. So we're just going to keep chugging along here. We have 2. Oh, I'm not sure why it keeps doing that, jumping around. We have 2 raised to the third power, number on the inside, divided by the power on the outside. We get another case of 2 to the first power, which is just going to be 2. So simplifying the radicals if possible. Oh, and it looks like I might have missed. I did. We'll jump back up to number 4 here in a second. On number 7, continuing this trend of getting an answer of 1, we have 2 to the 5th over 5, which will be 2 to the 1st, which is just 2. Now I'm going to jump back up here and make sure that I do this problem before I forget about it. But we have an invisible 2 on the outside. No index or no number on the outside means there's an invisible 2. And the setup is the exact same. Y to the 4 over 2 should be equal to, well, 4 divided by 2 is just 2. So my final answer is y to the second power. And then finally, number 8. I'm actually going to flip these two numbers. Let me see if I can do that. I can't. I'll talk about that here in a second, but let's set this up like normal. We'd have 3 to the 6 over 3. 6 divided by 3 is going to give me to the second power. And 3 to the second power, again, this is the same thing as saying, well, what's 3 times 3? Well, that's really just 9. So 6 to the third in this radical with an index of 3 is going to give me a value of 9. Now, let's say that these two numbers were switched around. I'm going to quickly do this. Let's say we had 6 as the index, x to the third. I'd have x to the 3 over 6. You would want to simplify this fraction down. 3 divided by 6, it can't be divided evenly, but it would give me x to the 1/2 as my final answer. So you won't always get a whole number for your power. Like a lot of these are whole numbers. You can get these fractional exponents that won't simplify immediately, but you can reduce the fractions to a more reduced form. So you do need to be aware of that. And now we're finally at the part of the notes where, depending on your teacher's personal preference, they might tell you how to do this a different way. For the purpose of these video notes, I'm going to show you how to simplify these radicals with a calculator. And this is what you can do, let's say on the STAR test or on some of your upcoming tests. It says simplify each radical. I am going to take these radicals with these numbers and I'm going to convert them to decimals. When we ask you on a multiple choice test, we're going to ask you to match these radicals with other expressions, like let's say 2 squared to 3 would be an answer. We would type both of these into the calculator to see if they gave me a similar answer. And if they did, well then answer choice A, or in this case, this would be our answer. But I'm just going to show you the calculator skills, and you can ask your teacher more specifically how they would like you to handle this. So I'm bringing up my graphing calculator. And this is a calculator that is available on CMS, and it's very easy to do this. We are going to say second, the blue button, and then we're going to go down here to where we have that x squared button. You can see the little radical sign in the blue. So it gives you the radical. We'll just type in 50, so 50, click enter. And we're really only going to go to about 2 decimal places. So the square root of 50, we're going to say is approximately, you do like a little squiggly equal sign. You don't say equals, we'll say the square root of 50 is approximately 7.07. Now there are other ways to simplify the radicals, but I am choosing to show y'all how to use a calculator. And your own math teacher might have a different way that they would like to show you. So make sure you're being a little flexible with this portion of the notes. For the next one, I'm going to do second x squared, or the radical. I'll type in 120. And it looks like we get approximately, the square root of 120 is approximately 10.95. And again, I would just type in all of my answer choices to see if they match this. And then finally, the square root of 20. Let me go ahead and pull this up. Let me move it over here. Second square root of 20. And we get it's approximately 4.475. Square root of 20 is approximately 4.47. And that about concludes these video notes. So just as a quick little review, having everything kind of side by side, we talked about how to change something from radical form to exponential. And conversely, we talked about how to change it from exponential to radical. So these are 2 big components, and honestly, a lot of the questions are going to be asking you. We then simplified those radicals. We took a radical, we wrote it in exponential form, and we just simplified the powers. So 6 divided by 3 gives me 2, and we just made it a nicer number. And then finally, I showed you how to use the calculators, second x squared, or second and then the little radical sign, and we're approximating the decimal value to match with our answer choices. So I hope these video notes were helpful, and if you have any more questions or concerns, please make sure to ask your teacher during your Zoom session.